I'm Tim Ventura from AmericanAntiGravity.com, and I'm speaking today with Mark Tomion, inventor and author of the book Stardrive Engineering, available at stardrivedevice.com. Well, Mark, thanks for joining us today. And for the first question, I'd like to start right out and ask, for the layman, is there a simple explanation of how your device works to produce thrust?
Well, Tim, not really. Uh, any explanation pretty much involves vacuum electronics, um, not solid-state transistor stuff we're familiar with, but good old vacuum tube theory.
Okay, well, as I understand it, the SEG was somewhat of a starting point for your inspiration. How are you able to refine the device and eventually obtain the patent on the Stardrive device?
Well, um, hmm. John's work was indispensable when it came to developing the hull configuration, which is derived almost entirely from his principles. I studied his work over many years, but the working hardware inside that's needed to produce that exterior star drive field envelope couldn't be more different, and that's actually what I patented.
Now, the device is essentially electrostatic in the way it produces thrust, isn't it? Is that different from an SEG in the way that it produces forward thrust, or is it fairly similar, I guess, in the way it lifts?
The field envelope is essentially the same, largely because of the shape of the hull. You get a dual hemitoroidal electric discharge flow of current across the exterior of the hull. Now, that discharge is electrostatic in nature, but the SEG produces that discharge, or produces the voltage for that discharge solely through magnetics. It's all magnetic, essentially a homopolar dynamo like Faraday's original, and it's closer to Faraday's disk dynamo by far than my own EDF generator, which produces the voltage for that exterior discharge by all electronic means.
Oh, okay. Well,
That's why I say any explanation involves vacuum electronics, essentially vacuum tube theory. You have both cold cathode um, emission of electrons from a surface, a metal surface, or if you have a hot cathode, it glows. Like in vacuum tubes we're familiar with, cathode discharge uses thermionic emission principles. Ken Shoulders has written an interesting paper called The Good, the Bad, and the Ugly, published just this year, which describes um, cold cathode electron emission from a metallic surface and describes that electrons are essentially self-propulsive in nature. Um, and the heavier the current density in an electric discharge in vacuum or air, and the higher the driving positive field voltage, the more self-propulsive they are until they actually will form charge clusters. Hal Puthoff has done work with charged clusters and how they are emitted or formed and emitted. And essentially that shape, the emitter ring, which is where the electrons collect for self-propulsive emission, is therefore largely recoilless, and the thrust is produced on the surface of the collectors um, relativistically. You have a differential between relativistic thrust produced by self-propulsive electrons on the collectors in the center of the hull. The difference between that and a strictly Newtonian and enormously smaller recoil on the emitter ring. Therefore, we say it's largely recoilless, and because you are getting a thrust differential produced between isometrically oriented vectors, one of the collectors faces north, the other faces south. Um, there's no net repulsive repulsive recoil, but a purely reactionless net thrust vector.
So the electrons are really what do the pushing in this case, making it more of an electrogravitic than maybe perhaps more of an anti-gravity device. But
Electro-inertial might be a good word because the electrons pay their own freight for zapping from the emitter ring, smashing onto the collectors. And there, yes, you're utilizing the electron's ability to absorb any amount of energy it needs to self-propel itself in most cases towards the speed of light if allowed. Yes.
interesting concept. Now, do you believe that there might be some gravitational interactions with this as well? I mean, in addition to the electron thrust, do you think that it might actually be warping time and space just a little bit around it, similar to maybe the SEG precursor design would?
If you combine the electro-inertial properties of the field envelope around the hull with a combined hull and field relativistic speed, then yes, you can use the Fitzgerald ratio, Lorentz foreshortening formula to to calculate a reduced volume for the ship and field combination. Now that's a it's an effect, yes, that it's not obviously the Lorentz foreshortening principle doesn't involve a subjective deformation of the object considered, but a true objective deformation of the space-time through which the object is moving. So yes, as you have a field velocity, the electrons in the field are under enormous driving pressure, 8 to 9 nines light, and their current density is almost but not quite to an uncontrolled arc discharge state. This wants to be an abnormal cold cathode discharge state. But yes, the field and hull begin to bend time and space, the time-space through which it's moving.
You know, I've read a number of different write-ups on electrons providing, I guess, a means of self-thrust, if you will, in that the field accelerates them, but that they impart momentum on whatever they finally impact. Talay had done some work, I believe, in the late 70s on a similar concept.
Yeah,
And
the higher the driving positive, the attractor positive voltage, and the greater the charge density on the emitting surface, the more proportionally self-propulsive a discharge between the two is. Yes, the electrons begin to impart more and more of the work done. In fact, until they're doing essentially all the work of producing the thrust on the collectors, and the machine is only creating the positive charge on the collectors, which takes a microscopic fraction of the total wattage involved in that arc or corona discharge envelope, however you like to describe it, the field envelope.
well, one of the things you touched on a minute ago when you mentioned Lorentz foreshortening and some of the other, I guess, relativistic effects, these fall into, in a way, some of the side effects categories of anti-gravity. And we've seen these occur from time to time in different experiments. A lot of them have been reported on a very small scale. But some of them include shielding effects, where things will actually bounce off in a visible field, or a kind of a black fog that might even be some kind of an event horizon phenomena. Are you predicting any effects like this while the device is in operation?
Well, somewhat to an extent, yes. I think that a quasi-coherent electron discharge field envelope provides an all electromagnetic and ready way to explain almost all of these phenomenon. If you impart just a very small amount of axial magnetism to the field configuration that both John's device and mine employs, you can tune the properties of that arc discharge and make it quasi-coherent.
So it becomes kind of a charge sheath then, if you will.
It, yes, yes, the intensely random lightning-like discharges smear out. You can use magnetism to smear that out and provide um, a more uniform current density in that field envelope, and you can put AC on it even, and use it as in my book I explore the idea of imparting AC ripple on the DC discharge field, and using it as a means of communication by having two of the same devices operating at the same resonant frequency.
Absolutely. Well, to switch gears just a little bit, one of the challenges that you encountered when you were designing this device was the theoretical overheating in load resistors. And one of the things I wanted to ask you about was many Searl Effect purists, because I guess his design is considerably different than yours. They claim that these devices, as a genre, I guess, tend to run cold. But I was wondering if you had any thoughts on that.
Well, yes, absolutely. John's is the better device because it runs cold. Um, his produces that field envelope by basically Faraday homopolar dynamo principles, and it doesn't produce the heat that my device theoretically must in operation according to classical principles. You have to have power resistors made of of certain ceramic materials connected between the collectors and the positive primary power system source voltage on the rotor. And the voltage drop across those resistors, according to classical theory, must produce enormous quantities of heat in my device. And what to do with all that heat in a starship size EDF generator becomes a study in thermodynamics, which is actually beyond my own ability to do properly. Someone will have to help me work out a means to get rid of that heat, unless it is, as I suspect, partially true, that the field envelope itself will absorb a good portion of that energy, because the electrons in the field envelope are using up such incredible amounts of spatial energy in that volume. If you understand, the field itself, in a vacuum discharge state, runs cold. Contrary to what people think, an arc discharge in space is at absolute zero, and therefore the field envelope should act as an enormous heat sink, provided it's fully evacuated.
Yeah, the electrons, in other words, take away some of that heat when they leave the surface of the cathode.
Well, by the time they smash into the surface of the anode or collectors, they, yes, they have absorbed probably about that equivalent amount of heat. So we're hoping that the cooling effect inherent in the field envelope about John's devices, since the field envelope theoretically of the two devices is precisely the same phenomenon, yes, we're hoping that the collectors will be actually not heated tremendously as they are in an X-ray tube. An X-ray tube isn't operating in the relativistic range yet, and therefore the target under, so let's say, 75,000 volts gets a lot of heat produced in it. They have to be liquid cooled in some cases. Well, we're hoping that when the electric discharge is operating in the incredibly relativistic range, that the electrons' energy bill is such that they themselves will use that energy, that thermal energy, up, because it is photonic, and electrons run on absorbed photonic energy or subphotonic energy. It depends on a point of view, but essentially, yeah, the electron operates in a sea of energy from which it gets its own fuel immortally forever. And thermal energy has to be in that realm somewhere, and so, yeah, we hope the collectors begin to run cool above a certain but still enormous driving voltage.
Well, one of the things when I mentioned this question to you last night, you would email me back and said that this was one of your 10 questions, one of the 10 things that you wanted to be able to tell the public about this device.
Well, I didn't necessarily say I wanted to tell the public, but it is one of the top 10 questions, jokingly, that I said nobody ever seems to think to ask me. Is that, yeah, and that goes back to the example of the X-ray tube. Um, Electron guns produce the beam they produce creates heat in its target, um, up to normally to normal driving voltages available in the laboratory. Um,
Well,
and
I,
yes, this heat would appear basically inboard, and how to get rid of all that heat becomes um, an extremely complex thermodynamic and technological problem. I'm working on an idea of using internally cooling diodes, internally cooled light emitting diodes, and trying to broad beam disperse that thermal energy into space uh, via laser energy. That's something that's going to require government level help with. If we can get some prototypes built and get close to, um, demonstrating the merit of the program, then hopefully the government would step in and help solve some of the last remaining but very substantial technological problems to be overcome, and that's the main one: what to do with the inboard heat, which theory says has to be produced unless the Searl effect compensates for it, which is something we can only find out by prototyping at that scale and level.
Absolutely. Well, and that's one of the things that I actually like about your design. In some ways, the Searle effect has always seemed a little bit too perfect, and that kind of worries me. It makes me wonder if maybe they just neglected some of these things when they did the theory for it. But, with some of the other ideas, I guess, some of the other important questions that you wish people asked you, any thoughts on things that you might be willing to share with us about that? Just the questions that you wish people had asked, I guess.
Well, I wish they had asked to indicate their level of interest and their level of understanding. It's one thing to be interested, but if it's just images going by, that doesn't help any of us develop this technology. The number two question that nobody ever seems to ask me is, what are you going to do about the tremendous quantities of radiation produced normal to the surface of the collectors? Going back again to the X-ray tube under high driving voltage, theoretically, according to all known standard models, the electron field envelope smashing into the collectors at 99.9 plus percent of the speed of light should produce literally blinding levels of very high energy radiation all the way up to gamma. And in fact, the field envelope theoretically of even small devices operates above the pair creation threshold. I talk about that in my book. Even the 4-foot device that I use as an example, a model, a visualizable model, throughout my book, would operate above pair creation threshold energies. And that's scary as can be. Now, again, we have a principle that we are examining to help further define the nature of the Searle effect field envelope, which, as I say, we feel is identical between his machine and mine, because it's totally exterior to the means by which it's produced. We have a theory we call kinetic occlusion. I would need Fran Diakino's help with this, believe it or not. And I was going to ask you at some point if maybe I was going to run by you just what I'm going to say right now. The impinging field current should theoretically occlude and largely reabsorb that radiation produced from the surface of the collectors, because that radiation has to struggle out and partially against it and partially across its trajectory of motion. Therefore, kinetic occlusion. Fran Diakino would be the absolute man to help me with this, because this is very much like his ELF photonic gravitic shielding principle, only in reverse.
Ah, well, and it's possible. He's been rather quiet lately, but I can definitely forward this on and see if he has any thoughts.
Well, it's something that right now, of course, we're concentrating on getting proof of concept low voltage electric power output models built. It's essential that we develop proof of concept for over unity operation before we can generate serious interest in the propulsive variant, because the propulsive variant totally presumes and assumes extraordinary coefficients of performance over unity.
In other words, the one of the other parallels maybe with the SEG, and I should apologize for returning to that because I know your design is, well, to begin with, it's patented, and secondly, it is a very unique design. But another possible parallel might be that your device generates electricity. It's not just propulsion. The baseline for it is energy.
Well, yes, the device is designed to be used as a practical low voltage generator, electric power generator as well. We have to kind of de-engineer, reverse engineer, or whatever the variant described, largely in the patent. I concentrated maybe too much in the patent on the propulsive variant, but we can simplify the device very, very much and produce, well, we're working right now on a 24 kW low voltage DC generator. It would put out 425 volts, and which is a common inverter voltage, so that we can produce useful AC power with it. But it will provide us, hopefully, with proof of concept in that the coefficient of performance achieved all electronically is still enormously greater than 1. Therefore we, hopefully we begin to get more and more interest in pushing voltages higher and higher, and finding that place where you begin to get Searl-like levity effects if you have the current envelope on the bottom be stronger than the one on the top. Now, this goes back to an idea you mentioned before, where it's hard to believe that Searl, 40 years ago, struck just that right balance between the field current density on the top half of the field versus the bottom, so that the inertial differential pointed up instead of down. He had to have had control over the current value in each half of the field, but he never has, to my knowledge, ever said anything about how he managed that.
Yeah, I wonder if maybe it was just an inherent part of his design, or perhaps something that the environment itself set. Maybe just being in the Earth's magnetic field, or being close to the surface, or it could be something completely also outside of what we're used to. Yeah, I've always liked to propose perhaps a relativistic approach for why it produces thrust, and that may run counter in some ways to another part of the proposed method. Instead of thinking electrons, I'd always wondered if maybe it wasn't creating a bubble of time and space around itself that was just being rejected by the Earth's field.
A magnetic bubble, you mean?
Well, I was actually thinking maybe a gravitic differential, almost like inflating a helium balloon underwater, where it would rise to whatever the natural level that it was supposed to be at was, except that, of course, with gravity instead of helium.
Well, I believe that in John Searle's case, of course, he's just a tremendous genius, and there's an incredible amount that he knows that he's never really revealed to us all, and probably now never will, which is very unfortunate. Hopefully that we can take everything we learned from him and fill in the missing pieces ourselves.
I absolutely agree. And I think your design is a step in the right direction because you've been able to work through all of these challenges to being able to come up with a robust design and addressing all the variables beforehand. And that's a big bonus so that it doesn't, overheat and melt at the last minute with nobody predicting it beforehand. You've at least been able to take these things into account.
Well, the beauty, one of the main things about my design, which hopefully will lead to experimentation, not just by myself, but others around the world, is that it is truly linearly scalable in all of the ways that count. And that just it makes it so much easier when you're dealing with such expensive materials and processes. Even our little 24 kW prototype, we expect to cost us $250,000 before we're done. And when you start talking about, oh, let's say some of John's machines were 10 to 20 feet in diameter, you're talking millions of dollars in the case of my technology to try to build that in such a way as you can control it when you're done. That is tremendously, hideously expensive, and that's why it's difficult for us to accept that we have to go through incorporating and stock offerings and begging, pleading with investors all over the world. Please help us, because until we get to the a prototypic level where the government and academia in this country will pay serious attention, we're struggling desperately here.
Well, one of the ways the public can help is by visiting your website. And again, that's stardrivedevice.com or www.stardrivedevice, all one big word, no hyphens or anything, .com. And your book, I believe, is around $25, isn't it? And that's entitled Stardrive Engineering.
$25.95 and $6.50 to ship anywhere in the U.S. and Canada. We can ship pretty much anywhere overseas too, which is it's gratifying that we have now reached a largely worldwide audience. We just like to hear from more of the local people here in the U.S.
Absolutely. Well, thanks again for your time, Mark. I sincerely appreciate the opportunity to get something on record about your work, and it's a wonderful opportunity to catch up on what the recent developments have been.
Well, you're very welcome, Tim, and thank you for talking with me.
Thanks.